Thomas Midgley Jr. received the Nichols Medal in 1923, the Priestley Medal in 1941, the Perkin Medal in 1937. He was elected to the National Academy of Sciences, appointed President of the American Chemical Society, and celebrated in every serious chemistry journal published in the English language during his lifetime. He also has the highest body count in geological history, not approximate, not metaphorical, geological. His inventions altered the composition of the Earth's atmosphere and contaminated the blood of every human being alive between 1925 and 1986. Every single one. Blackwell here, and this is the part where a normal channel would say he was a monster, a villain, a madman in a lab coat. He was none of those things. He was Employee of the Month. He was the man who solved the problem his bosses asked him to solve, collected his awards, and never once asked what happened after the product left the factory. That question is the one Blackwell has been asking, and the answer took decades to find because the people who should have been looking were the same people writing the checks. 2 inventions: tetraethyl lead, chlorofluorocarbons. One went into gasoline, the other went into refrigerators and aerosol cans. Between them, they poisoned the blood supply of a species and punched a hole in the shield that keeps ultraviolet radiation from sterilizing the surface of the planet. Both were invented within 8 years of each other. Both were celebrated as miracles of modern chemistry. Both were defended by the same company, the same lawyers, and the same strategy. And both were invented by the same man. The question is not whether Thomas Midgley Jr. caused harm. That part is settled. The question Blackwell cannot stop turning over is simpler and worse. How did he keep winning awards while doing it? How did an entire scientific establishment watch this happen for 40 years and hand him trophies? How did the system that is supposed to catch exactly this kind of catastrophe not only fail to catch it, but actively celebrate the man at the center of it? That is the investigation. To understand Midgley, you have to understand the room he walked into. Dayton, Ohio, 1916. The Delco Research Laboratory, funded by General Motors. Charles Kettering ran the lab. Kettering was an inventor himself, brilliant and restless, the kind of man who saw a technical problem the way a terrier sees a rat. He did not let go. The problem in 1916 was engine knock. Internal combustion engines were getting more powerful, but the fuel could not keep up. When gasoline ignited too early in the cylinder, it created a sharp metallic hammering sound. Knock. It was not just noise, it destroyed engines. It limited compression ratios. It was the bottleneck between where automobiles were and where General Motors wanted them to be. Kettering assigned the problem to a young mechanical engineer named Thomas Midgley Jr. Midgley was 27 years old. He had a degree from Cornell. He was energetic, creative, and spectacularly good at applied chemistry, despite having almost no formal training in it. He was the kind of person who read a textbook in the evening and ran an experiment in the morning. He worked fast, he worked cheap, he got results. His assignment was simple: find something you can add to gasoline that stops the knock. Midgley tried everything, literally thousands of compounds. He tested iodine, he tested aniline, he tested selenium compounds, tellurium compounds, tin compounds. He tested diethyl telluride, which worked fairly well against knock, but made everyone in the laboratory smell so terrible that Midgley's wife refused to let him into the house. His colleagues could reportedly smell him from across the building. The tellurium phase was brief. By 1921, Midgley had tested tens of thousands of combinations, and he had found the answer. Tetraethyl lead. A few cubic centimeters per gallon, and the knock vanished. The engine ran smooth. Compression ratios could climb. General Motors could build the bigger, more powerful engines they wanted to sell. There was one complication: lead. Lead had been known to be toxic for literally thousands of years. The Romans knew it. Benjamin Franklin wrote a letter in 1786 listing the occupational diseases caused by lead exposure. By 1921, the toxicology of lead was not a mystery. It was a settled question. Lead damages the brain. Lead damages the kidneys. Lead damages the nervous system. Lead is particularly devastating to children. This was known. This was in textbooks. This was not a secret. Midgley knew it too. In January of 1923, Midgley wrote a letter. The letter went to a colleague, and it said, in plain language, that tetraethyl lead was dangerous to handle. This was not a guess. Midgley himself had been experiencing symptoms. He was having trouble sleeping. His hands trembled. He felt confused. He took a leave of absence in the spring of 1923 to recover from what his doctor diagnosed as lead poisoning. He went to Miami. He spent several weeks on a beach. He came back to Dayton, and he went right back to work on tetraethyl lead. This is the first version of the story that people reach for when they try to explain what happened. He did not know. He was ignorant. Lead's toxicity was not well understood. It was a different time. Check the record. He knew. His own body told him. His own doctor told him. He wrote it down. And he went back to work. But Midgley was not acting alone. This is where the second version of the story collapses. General Motors did not want to sell tetraethyl lead by itself. General Motors wanted to sell cars. What General Motors needed was for every gas station in America to sell leaded gasoline, so that every General Motors engine could be designed for higher compression ratios. The scale of the operation required partners. In August of 1924, General Motors and Standard Oil of New Jersey created a joint venture. They called it the Ethyl Gasoline Corporation. The name was chosen carefully. Not the Lead Gasoline Corporation, not the Tetraethyl Lead Corporation, the Ethyl Corporation. Ethyl, like a woman's name, friendly, unthreatening. DuPont manufactured the tetraethyl lead. Standard Oil blended and distributed it. General Motors held the patent and collected royalties. The three largest industrial corporations in the United States were now invested in putting lead into every gallon of gasoline sold in America. Thomas Midgley Jr. was the public face. And then the workers started dying. October 1924. Standard Oil's experimental refinery in Bayway, New Jersey. The plant produced concentrated tetraethyl lead. Working conditions were what you might expect at a facility where men handled one of the most toxic organic compounds in existence with minimal protection in enclosed spaces. The workers called the building the Looney Gas House. They called it that because the men who worked there went insane before they died. Hallucinations, violent paranoia, convulsions. 5 workers died at Bayway in a single week in October 1924. 35 others were hospitalized. Some of them ran through the hallways screaming at things that were not there. The press covered it. The New York Times covered it. The public was alarmed. Government officials were asking questions. Standard Oil needed someone to stand in front of the cameras and make it go away. They sent Midgley. On October 30th, 1924, Thomas Midgley Jr. held a press conference. He stood before reporters and he demonstrated the safety of tetraethyl lead by pouring it over his hands. He washed his hands in the substance that had just put 35 men in the hospital and put 5 in the ground. He held a bottle of it under his nose and inhaled the fumes for 60 seconds. He told the reporters he could do this every day without any harm whatsoever. He told them the workers at Bayway had died because of their own carelessness, not because of any inherent danger in the product. He was calm. He was confident. He was convincing. He was also lying. and he knew he was lying because he had been hospitalized for lead poisoning the previous year. That press conference is the moment Blackwell keeps returning to, not because it was the worst thing Midgley did, but because it was the template, the playbook. Demonstrate safety in a controlled room. 60 seconds of theatre. Ignore what happens outside the room. In the refineries, in the atmosphere, in the blood, over decades. The playbook would be used again, by the same people, for the same product, and then for the next one. The public was not entirely convinced. The United States Surgeon General convened a conference. May 1925. The Public Health Service brought together scientists, industry representatives, and government officials to determine whether tetraethyl lead should be allowed on the market. The scientists spoke first. Alice Hamilton, the leading authority on industrial toxicology at Harvard, told the conference that leaded gasoline represented a serious public health hazard. She said that once lead was dispersed into the atmosphere through automobile exhaust, it could not be recalled. She said the long-term consequences were unknowable, but potentially catastrophic. She was specific. She was credible. She was correct. The industry representatives spoke next. They said there was no evidence of harm to the general public. They said the Bayway deaths were an occupational issue, not a consumer issue. They said they would fund a study. They asked for time. The Public Health Service made its decision. Tetraethyl lead was temporarily suspended while a committee investigated. The committee was given 7 months. 7 months to evaluate a substance that would remain in the atmosphere for 60 years. The committee met. The committee reviewed the existing data, which was limited because the long-term effects of atmospheric lead dispersion had never been studied. Because leaded gasoline had not existed long enough for those effects to manifest. The committee concluded that there was no evidence of harm from the use of leaded gasoline by the general public. No evidence of harm, because nobody had looked. The temporary suspension was lifted. In 1926, tetraethyl lead went back on the market. The Ethyl Corporation resumed sales. The study that the industry had promised to fund was never completed. The trail went cold. For decades. Leaded gasoline spread across the United States, then across the world. By the 1960s, virtually every gallon of gasoline sold on the planet contained tetraethyl lead. Automobile exhaust deposited lead particles into the air, into the soil, into the water, into the food chain, and into the blood of every human being on Earth. Nobody measured it. Nobody studied it. The Ethyl Corporation had said it was safe. The Public Health Service had cleared it. The case was closed. Until a geochemist in California decided to measure something that nobody had thought to measure before. Claire Cameron Patterson, born 1922 in Mitchellville, Iowa. Patterson was not a toxicologist. He was not a public health researcher. He was trying to determine the age of the Earth using lead isotope ratios in ancient meteorites. It was pure science. It had nothing to do with gasoline. But Patterson had a problem. His samples were contaminated. Every time he tried to measure the natural lead content of ancient rocks, the results were skewed by what appeared to be an enormous amount of lead contamination in his laboratory. He cleaned his lab. He rebuilt his instruments. He created one of the first ultra-clean laboratories in the world. He still found contamination. And then he realized it was not his laboratory. It was the world. The lead was everywhere. In the air, in the water, in the ice, in the soil, in the ocean. Patterson started measuring lead levels in ocean sediments at different depths. Deeper sediments were older. Older sediments had less lead, much less. The lead concentration in the surface layer of the ocean was hundreds of times higher than the natural background level. Patterson published his findings in 1965. The paper was titled ___, quote __, 0 ___. The conclusion was unambiguous. The lead in the environment was not natural. It was industrial, and the primary source was tetraethyl lead in gasoline. The Ethyl Corporation responded the way Blackwell has learned to expect. They did not dispute the data. They disputed the man. They tried to defund his research. They pressured the California Institute of Technology, where Patterson worked, to silence him. They hired their own scientists to publish contradictory papers. They lobbied the Public Health Service to exclude Patterson from advisory panels. Patterson spent 20 years fighting them. 20 years of measurements, publications, congressional testimonies, and personal attacks. 20 years of being told that his data was alarmist, his conclusions premature, and his motives questionable. He was right about everything. They knew he was right. The internal documents of the Ethyl Corporation, which became public decades later, showed that their own scientists had confirmed Patterson's findings as early as the 1970s. They suppressed the data and continued selling leaded gasoline. The lead investigation alone would place Midgley in a category of harm that is difficult to quantify. But there is a second chapter, and the second chapter makes the first look like a rehearsal. 1928. Midgley was reassigned. The problem this time was refrigeration. Home refrigerators in the 1920s used ammonia, sulfur dioxide, or methyl chloride as refrigerants. All three were toxic. All three leaked. In 1929, a methyl chloride leak at a Cleveland hospital resulted in more than 100 casualties. Frigidaire, a division of General Motors, needed a safe refrigerant, something non-toxic, non-flammable, chemically stable. They turned to the man who had solved the knock problem. Midgley and his team tested hundreds of compounds. Within 3 days, they had identified a class of chemicals that appeared to meet every requirement. Chlorofluorocarbons, CFCs. Specifically, dichlorodifluoromethane, which Midgley branded as Freon. Freon was everything the engineers wanted. It was non-toxic. You could breathe it without harm. It was non-flammable. It was chemically inert, meaning it did not react with anything. It was stable. Spectacularly, impossibly stable. Midgley demonstrated it the same way he had demonstrated tetraethyl lead, in front of an audience. At a meeting of the American Chemical Society in 1930, Midgley inhaled a lungful of Freon and used it to blow out a candle. The audience applauded. The message was clear. This substance is so safe that a man can breathe it. This substance is so inert that it extinguishes flame. The audience applauded because they were watching a 60-second demonstration in a controlled room. Outside that room, the same chemical stability that made Freon safe to breathe made it indestructible in the atmosphere. CFCs do not break down in the lower atmosphere. They rise. Slowly, over years and decades, they drift upward into the stratosphere, where ultraviolet radiation finally has enough energy to crack them apart. When CFCs break apart in the stratosphere, they release chlorine atoms. Each chlorine atom destroys ozone molecules. Not 1, not 10. Each chlorine atom can destroy up to 100,000 ozone molecules before it is finally neutralized. The ozone layer is thin. If you compressed all the ozone in the atmosphere into a single layer at sea level pressure, it would be roughly 3 millimeters thick. 3 millimeters between the surface of the Earth and the full intensity of ultraviolet radiation from the sun. Ultraviolet radiation that would sterilize exposed surfaces, destroy crops, blind animals, and cause epidemic rates of skin cancer in humans. Midgley did not know this, not in 1930. The stratospheric chemistry of CFCs would not be understood for another 44 years. But here is the question that Blackwell finds difficult to set down. He did not know what CFCs would do in the stratosphere. But he also did not ask. He tested whether the substance was toxic to breathe. He tested whether it was flammable. He did not test what happened when you released it into an atmosphere and waited. The same methodology, the same blind spot. Demonstrate safety in a room. Do not ask about the sky. CFCs entered the market in 1930 and spread even faster than tetraethyl lead. Freon went into refrigerators, air conditioners, aerosol spray cans, foam insulation, fire extinguishers, and industrial solvents. By the 1970s, hundreds of millions of tons of CFCs had been released into the atmosphere. Every one of those molecules was still there, drifting upward, waiting for the ultraviolet light that would crack it open. In 1974, two chemists at the University of California, Irvine, published a paper. Mario Molina and Frank Sherwood Rowland. The paper was titled Stratospheric Sink for Chlorofluoromethanes, Chlorine Atom Catalyzed Destruction of Ozone. The title was technical. The conclusion was not. CFCs were destroying the ozone layer. The chemical industry responded the way the Ethyl Corporation had responded to Claire Patterson. They attacked the science. They attacked the scientists. DuPont, the world's largest manufacturer of CFCs, called the ozone depletion theory quote 2, quote 3, and quote 4. Quote, the chairman of DuPont said the ozone theory was not backed by scientific evidence. Industry-funded scientists published contradictory studies. Lobbyists descended on Congress. Molina and Rowland spent years defending their work. Rowland later described the experience. He said that after publishing the paper, he was essentially shunned by parts of the scientific community that had financial ties to the CFC industry. He said that for years, his department at UC Irvine could not hire new faculty because no one wanted to be associated with the controversy. They were right about everything. In 1985, a team of British scientists, led by Joseph Farman, published measurements from the Halley Research Station in Antarctica. The measurements showed that the ozone layer above Antarctica had thinned dramatically. Not a small decline, a hole. The Antarctic ozone hole was losing ozone at a rate that shocked even Molina and Rowland. By some measurements, stratospheric ozone over Antarctica had declined by more than 60%. NASA had actually been collecting the same data from satellites for years. Their instruments had detected the ozone decline, but the software that processed the data had been programmed to flag extreme values as errors and discard them. The computer saw the ozone hole and decided it was too extreme to be real. The machine threw away the evidence. That detail is one Blackwell cannot stop thinking about. The instruments measured the catastrophe accurately. The software decided the catastrophe was an error. The human beings who wrote the software had programmed it to reject exactly the kind of result that should have triggered alarm. The Montreal Protocol was signed in 1987. 197 countries agreed to phase out the production of CFCs. It was the fastest and most comprehensive environmental agreement in history. DuPont, which had spent 13 years denying that CFCs damaged the ozone layer, announced that it would stop manufacturing them. The ozone layer is recovering, slowly. Current projections suggest it will return to 1980 levels by approximately 2066, 40 years from now, 80 years after the Montreal Protocol, 136 years after Thomas Midgley Jr. inhaled Freon and blew out a candle. Now, here is where the two threads come together, and here is what the investigation has been building toward. Tetraethyl lead, chlorofluorocarbons, two substances, one man, same employer, same methodology, same defense. Demonstrate safety in a controlled room. Inhale it. Wash your hands in it. 60 seconds. Applause. do not measure what happens outside the room, over years, over decades, in the blood, in the sky. When scientists measure, attack the scientists. When the public worries, fund a study that never concludes. When governments investigate, send a charming man to a press conference. The pattern is not Midgley. The pattern is the system. But Midgley is the proof that the system works. Because the system did not hide him. The system rewarded him. Publicly, repeatedly, enthusiastically. The Nichols Medal, 1923, for the discovery of tetraethyl lead. The award citation praised the contribution to automotive engineering. The Willard Gibbs Award, 1942. The Priestley Medal, 1941, the highest honor the American Chemical Society can bestow. The Perkin Medal, 1937. He was elected president of the American Chemical Society. He was inducted into the National Academy of Sciences, every award in chemistry, given to a man whose two most celebrated inventions turned out to be the two most destructive chemical products of the 20th century. Given while the evidence was accumulating, given while workers were dying, given while the lead was settling into soil and water and bone. The system did not fail to catch Midgley. The system was not designed to catch Midgley. The system was designed to reward the person who solved the problem that the employer defined. The employer defined the problem as engine knock. Midgley solved engine knock. The employer defined the problem as a safe refrigerant. Midgley delivered a safe refrigerant. Safe in the room, safe for 60 seconds, safe on the terms that the employer set. The terms did not include the atmosphere. The terms did not include the blood supply of the human species. The terms did not include the ozone layer. Those were externalities. Those were somebody else's problem. Those were, in the language of corporate accounting, off the balance sheet. Let Blackwell tell you how Thomas Midgley Jr. died, because even his death follows the pattern. In 1940, at the age of 51, Midgley contracted polio. The disease left him severely disabled, unable to get out of bed without assistance. Midgley, who had spent his career solving problems with engineering, designed a solution. He built an elaborate system of ropes and pulleys attached to his bed that allowed him to lift and turn himself without help. On November 2, 1944, Thomas Midgley Jr. was found strangled in his own bed. The rope and pulley system he had designed had become tangled around his neck. He was 55 years old. The man who had designed two of the most lethal chemical products in history was killed by the last machine he ever built. There is a symmetry to that which Blackwell does not find poetic. Blackwell finds it precise. Every machine Midgley built did exactly what it was designed to do, and every machine Midgley built eventually killed someone. The environmental historian J.R. McNeill wrote that Thomas Midgley Jr. had more impact on the atmosphere than any other single organism in Earth's history. That sentence is from a peer-reviewed academic text. It is not hyperbole. It is not metaphor. It is a measured assessment based on the atmospheric data. Leaded gasoline was not fully phased out in the United States until 1996. 70 years after Alice Hamilton warned the Public Health Service that the long-term consequences were unknowable but potentially catastrophic. The long-term consequences were knowable. They were catastrophic. She was right. She told them in 1925. They did not listen until 1996. Globally, leaded gasoline was not eliminated until 2021. Algeria was the last country to stop selling it. 2021. 99 years after Midgley first added tetraethyl lead to gasoline in a laboratory in Dayton, Ohio. During those 99 years, every study that attempted to estimate the health effects of atmospheric lead reached the same conclusion. The numbers are so large that they resist comprehension. hundreds of millions of children with measurable neurological damage from lead exposure, IQ points lost across entire generations, billions of people with lead levels in their blood that would be considered dangerous by current standards. The CDC has revised the safe blood lead level downward repeatedly. The current position is that there is no safe level of lead exposure. 0. The safe level is 0. And for 99 years, the level was not 0. The level was everywhere. CFCs are still in the atmosphere. The molecules Midgley's invention released in 1930 are still drifting in the stratosphere, still breaking apart, still releasing chlorine, still destroying ozone. They will continue to do so for decades. The ozone layer is healing, but it has not healed. The hole still opens over Antarctica every spring. The ultraviolet radiation that reaches the surface of the southern hemisphere is still elevated. The increased rates of skin cancer in Australia and New Zealand are still measurable. 2 inventions, 1 career, both initially celebrated, both vigorously defended by industry, both attacked when scientists raised concerns, both cleared by government agencies that accepted industry data, both catastrophic on a scale that the word quote 7 does not. Stavomiesta gdzie ona barwalsa adequately contain, and the man who invented both of them was not punished, was not investigated, was not stripped of his awards, was celebrated until the day he died and for decades afterward. The Midgley Award, given by the American Chemical Society's Cincinnati section, was named after him and continued to be awarded until it was quietly renamed. The system that produced Thomas Midgley Jr. did not malfunction. That is the conclusion Blackwell reaches after turning this over for longer than is probably healthy. The system functioned exactly as designed. It identified a man who could solve problems quickly and cheaply. It rewarded him for solving those problems. It did not ask, and was not structured to ask, what happened after the solution left the laboratory. The question is not why Midgley did what he did. Midgley did what every incentive in his environment told him to do. He solved the problem. He collected the award. He moved on to the next problem. The question is why the system that surrounded him, the corporations, the regulatory agencies, the scientific societies, the awards committees, never once asked the question that Blackwell cannot stop asking. What happens outside the room? What happens after 60 seconds? What happens when you pour something into the atmosphere and wait? They did not ask because asking was expensive. Not asking was free. That is not a historical observation. That is a current condition. If you watched the last video, the one about Baltimore, you saw how corporate lobbying shaped a city's infrastructure for a century. Midgley is the next chapter. Baltimore was about what happens when corporations control policy. Midgley is about what happens when corporations control science. The lobbying built the road. The chemistry poisoned the air above it. And if you stay for the next one, Blackwell is going to show you what happens when the engineering fails in real time. Not chemistry, not policy. Steel and gravity. 3 engineers looked at a bridge design and said it would fail. A 4th engineer said it was fine. The bridge was built, and what happened next is the reason Blackwell does not trust the phrase expert consensus without checking who was in the room when the consensus was reached. Blackwell.